Hi guys, welcome back to my YouTube channel. Today we are going to continue GFG 160J challenge problem series and we are at day 11. Problem is maximum product subarray and the difficulty level is medium. So let's read the problem statement. So we have given an array that contains positive and negative integers and may contain 0 as well. Find the maximum product that we can get in a subarray of array. So here there is a note also. It is guaranteed that the output fits in a 32-bit integer. So there is no problem to storing the storage layer. So we have given input array -2, 6, -3, -10, 0, 2, and then output will be the 180. So let's see the explanation. The subarray with maximum product is 6 -3 -10 with product 6 into -3 into -10, that is equal to 180. So like this we have an array -1 -3 10 0 6. So here we are getting 30 in output. And in third example we have given array just containing the positive elements. So just we here we are simply doing the multiplication for getting the maximum subarray problems, right? So the problem is here, like in the third example it is very easy, like just we are going to product the all elements, right? But the when the problem is when we have a -1 and 0 containing in the array, right? So how we are going to approach, like if we multiply, let's see this example, -2 6 -3 -2 6 -3 -10 0, and array is, let's see, -2 6 -3 -10 0 2, right? 0 2, and the product is 180, right? So if we have array of containing just positive integers like 6 2 3, right? So just we are multiplication here, 6 into 2 into 3, right? Then 12, and it will be 36, right? So we are getting here just 36, simply multiplication we are doing here. But the problem arise when we have a negative value, right? When we have a negative value and 0. So this is the problem, this will create the problem. So let's then how can we solve? So let's possible sub array I'm just going to take. So in my previous example, when we are solving the Kadani's problem, there is also like we have to find the maximum sub array sum, right? So there we are approaching like we are solving the array, taking the previous one and the next one, then next one and then previous one and the whole. What do mean here? Like this is a subarray, this is also subarray, this is subarray, this is subarray, this is subarray, right? So like this we can get the in Kadani's problem we are solving the maximum subarray sum, but here just uh, change is like maximum product of some subarray here. So what we are finding, maximum subarray product, or you can say maximum product subarray, right? So first, what is the possible subarray that will, if we will multiply those elements of the subarray and we will get the maximum product? So we need to find this one. So the idea is about like It could be the maximum product, only the single element if array contain only one element, right? Then let's see minus 2 and 6. What is the possible? Minus 12, right? But minus 2 and 6, we are getting, after multiplying we are getting minus 12, but 6 is greater than minus 2. So then in this case 6 will be the only element, and 6 is the sub array that is maximum. So let's see minus 2, 6 and minus 3 for example. So for this one maximum is 6. We find out here maximum is 6. But for this one, this is 12. No. For this one, 6 into minus 12 into the minus 3 is 36. We are getting positive 36. If we look this array, this sub array, so we are getting just minus 18, and minus 18 is less than 6 also, and minus 18 is less than 36 also. So what we are doing here, we are doing the we are searching that element, the current element and the previous element with the multiplication, and the next previous element with the previous two, and the current two and the current one, right? So the intuition is here. First we have to take the three variables. Let's say current minimum, current maximum, and a maximum product. Here what we are doing, we are doing the product also, and then we are looking the what is the maximum, what is the minimum, then maximum, then minimum, then we are comparing like minimum maximum we are finding after multiplications with the current one also, and the previous one to previous one and the next one, right? So for that one we are assume these three variables: current minimum, current max, and then current product. The second step is like, now we initialize these three variables with the just array first element. Okay, so what will be the next approach? Now here how to find the current minimum and how to find the current maximum, and then how we'll find maximum product. So first let's say if we will get the current minimum and current maximum, then we will update the our maximum product also. So let's, then we will get current maximum first we will find. So we will take max, but the current element and these two product, right? The next elements with the previous element, product of the these two elements. So first we will find the first element, maybe current elements, you can say I is our current element. Okay, and add up I, and we will product the our current minimum, and then we will product our current maximum, then we will find the our current maximum. Here we have initialized current minimum and current maximum with the first element, right? With the first element, so we you have the values for these two values, and the current air of I is the current index, we can say current element. Then third steps are in, you can say in third one we will find the current minimum also. Every time when we will product with the previous product, previous values of the product, every time we will update our current minimum and current maximum. So we are going to keeping the whole records every time we will find. Like here you can say if I will take these sub array, right, till the 0, any of number, if we will multiply with 0, then we will get 0. Then we will break this array and then we will start with the new one. That is why I'm taking the current element is also. You can say here, like, what if instead of 6, we can have a like a maybe you can consider like a 6 6 6. So this is the maximum value. If you will multiply with the minus 3 or minus 10 or 2, 0 is a breakable here, so we will not consider 2, because so in in this scenario our maximum value is the uh, double six double six, right? So that is why we are taking our current element also and product of the previous elements. Okay, so like this we will find our minimum. Let's say here maximum is double six double six and the previous element is minus 2, and these two multiply is the minus 2 into double six double six, and then again we are multiplying minus 3 into double six, right? So these two elements and these two elements and then these three elements, we if we multiply, then we will find, here we are finding in these three elements what is the possible maximum product, right? So that is why I'm taking like maximum of array of I multiply with the current minimum and array of I multiplication with the current maximum. Then we are also finding what is the minimum, so that we can take this minimum and we will update in the next iteration. Okay, so minimum of array of I and array of I multiplication with the current minimum and array of I and multiplication with the current max. Okay, then finally we will update with the maximum product with our current max. But I am not going to take the current max here. I will assume this is our temp value, because in the final we have to update this value. So for this, then I will update current max with our temp value, and maximum product is um I'll reach so that I can. Okay, you can consider this one is comma. It's not working. Why? Okay, it's not working. So let's say then we will get here like current maximum, current minimum, right? So then again we will update that this value to maximum prod. Okay, okay, it's working now. Thank God. The, oh, and then max prod will is equal to maximum of these two numbers. Let's say current maximum is 36 and our maximum final maximum product is 100, so that we can find the our max value. So 100 will be max here, not the current maximum. Let's assume after 0 there is a new array like 2 3, just some containing some positive values or negative values both. After this maybe we will get the maximum product. Okay, so here we are breaking our with the, like we when we will get the 0, then current minimum is 0, current maximum will be 0, right? But after this we have a possible sub array also. That is why every time we are updating the current maximum value, and then we are finding the current maximum value with the temp value, and then we are finding the maximum of max product and current max. Okay, so let's see how we will implement in our code. So it's very easy, just few lines of code we will write. Just here, the problem is, first understand the problem statement, and the intuition behind this problem, like how we are approaching this problem. And just take an example and do the dry run case here, so you can get in simple way. So first we will consider our variable initialization with the first element. Let's say current min our array of 0, and then again current max is also 0, and then our max prod is also our first element. And then we will traverse the array for I and range 1 comma length of array, and then we will consider the temp variable for finding the maximum product. Okay, max of array of I, and then current min multiplication with the current element I. Then again we will find the current max with the current element. So what will be the product here with the current element and current minimum and the current maximum with the product of current element, right? And then we will find the current minimum is equal to minimum of same array of I, and current min star current element, and then current max star current element. So like this we will get our current minimum also. Then we will update in third step, we will update the current maximum with the temp variable. What we will get the maximum product. So current max is equal to temp, and then again finally we will find the max prod is equal to maximum of max prod and our current max, and then finally we will return it max prod. Okay, so maximum array of I, let's see, let's just one check. This is okay. Let's compile and run. Max prod is not defined, so basically P in uppercase. Okay, so our output is 180 and expected is also 180. So let's submit the code. Yeah. So all the test cases are passed here. And if we'll see this problem is the medium level, and this problem is related to our dynamic programming. So if you don't know about the dynamic programming, first read some concepts about this. And we can also solve this question in time complexity of order of n square. But this approach is gives the our optimal solution, and that is the order of n in time complexity. And we are here storing just three variables, so we are not taking the yeah, space complexity more than order of one. So yeah, if we are approaching the problem in other like brute force, you can solve that this problem with the brute force approach, but that is not the optimized way. So yeah, so this problem is this approach is optimal approach. So thank you guys for this today. I'll meet you in the next video in the next day, and till that, just keep learning and keep growing.